Welcome all. In this tutorial I want to show you how to use new feature in RayFire 1.61, and it's called RayFire Cache. And the main purpose of this plugin is to cache all these massive simulations which you sometimes may create, like something like this. And to show how to use it, I will use this scene. Here's some information about this scene. As you can see right now, there are more than 1 million polys, and the amount of fragments is 4,700 fragments, about like that. And the file size right now is, here's this full baked max. It's about 529 megabytes. And here's this animation, just a wall explosion, nothing special. And pretty dense simulation, as you can see, it's very slow in viewport. No way to play back it in real time, of course. Okay. So, okay, now I will show you how to use RayFire Cache. You can find it in create geometry or RayFire category. So here's the subject. You need to create it in viewport like any other objects. And here's the properties, parameters. Here you can define icon size, display icon. Here you can see the file name which you use. Right now it's none. In status panel you will be able to see how much memory it takes. Here you can define name for cache file you want to record, but usually you will be able to do is just hitting the record button here. So when you will hit it, it will allow you to pick name and folder where you want to store your cache file. So using the load button you can load already cached animation. Also you can unload it in case you don't want it, or reload in case this cache file was changed. In file info rollout you will be able to see all kind of information of cached file. I'll show you later. So now let's start with this record rollout. Since right now we need just to record all this animation, and to do so you need to use this bottom buttons. Pick one will allow you to pick object by object, but of course in this case it's better to use this add button and add all these fragments. I will not cache the cylinder which I used to hit the wall. I'll actually delete it right now. Okay, now let's see when my animation start. So it start about at frame 53 and ends at frame 250. So step size defines quality. In case later you will want to make it slower, you can increase step size, but I guess it'll make your cache file more. But so you just use 1 by default. Or if you want to make your cache file less, you can use step size, let's say 2 or higher. Using range button you can define start and end. So your start frame here, timeline first frame, and this last frame timeline to the end. And using this button you can select objects inside this list in case you want to remove some of them. Okay, so before I start recording, here's explain what means the save material library. Right now I have this simple material for all these fragments, and let's say I will create another material. Let's say red one, select some fragments and apply this red material to them. Okay, so I have right now I have 2 materials, And if I will record cache file with save material check on, it will save cache file with all the geometry, all the animation, and also it will save another file which will contains material information. So later you will be able to load your cache file in completely different scene, and if it will find material file with the same name, it will load materials as well. So I will save material right now. Now I can hit record button. So I will open. Okay. I'll call it just to use. Okay, say all. So here you can see how it cached it. Might take some time. Okay. Now it looks like all the animations cached. And I will move for a second this cache file right here. So here you can see this one is one cache object, and here all the fragments. And I don't need these fragments anymore, so I can delete them. But one important note is that before if you will decide to delete just cached objects, and you have a lot of objects, it's reasonable to remove these fragments from this list before delete them. Otherwise, you will have to wait a lot of time. You can do this by selecting these elements in the list and clicking by remove. But if you want to remove all the fragments from the list, you can hold shift button and click remove. Okay, now I can delete fragments, and now I have only this cache file, and I will save it. Wall cached. And now let's see what I have. So here's what was original size of baked scene, 529 megabytes, and here's cached one. As you can see, it only 236 kilobytes, just because it doesn't contains any mesh data and any animation data. And if I will click here all files, so here's my cache file, and also there's this wall material file. Okay, now I will show you how this material file works. So I will just reset this scene. Okay, so now just clean scene, there are no any materials, and I will create this empty cache file, and now I will load. And as you can see, it loads all the materials as well. If I will pick this material right now, I will get this multi sub-object material. Okay, now now we can see all the information, by the way, in this file info allowed. And here's the file size, 146 megabytes, and you can see that 100 megabytes to take mesh data, and animation take only 43 megabytes, and there are 4,690 nodes. Okay, we are done with this, and by the way, here you can see how many memory it takes in RAM. Right now it's only 224 kilobytes, but if I will start playback it, take more. You see it here. I'll show you later how to preload all the memory, all the animation into memory, or not, or only use one frame at a time. Okay, right now let's move to this playback rollout and this viewport render rollout. So before I start showing you all this playback properties, I want to show you this viewport and render rollout, because right now there are still more than 1 million polys, and it's still hard to playback all this and update all this mesh inside viewport. As you can see, it's still slow. So here we can use this viewport, different custom properties for viewport and custom for render. As you can see, my mesh is pretty dense, a lot of faces, so it's now not surprised that the viewport is so slow. So first property is display cache. Just display all the stuff, and that works only for viewport. You still will be able to see everything on your renders, even though it's off here. Next one is force wireframe to make it faster, but usually I'm using this bounding boxes mode. It just replaces all the elements by this bounding boxes, and in this case it becomes really fast, like real-time fast. So you can start playback it in real time and see all the animation in real time. And again, this works only for viewport. On your renders still will have all the detalization. Another property is interpolate. What it allows to do, it makes well, it interpolates. It makes quality better. So if you want to get all the stuff, it's on by default for rendering, but if you want to get top quality, you can use it for viewport as well. The high invisible objects properties, I will show you later how to use them, and I will have some invisible object. And here's the render properties. So again, you can set bounding boxes for rendering as well, so you'll get some quick renders. And okay, now after I set bounding box here and my playback is pretty fast, I can show you all the playback properties. And the first property is the start frame. It's very simple. It defines the start frame where you want to start your animation, so you can copy it to another cache file, set here to, let's say, 50, I don't know, 15. So simply I've set all the animation. Another property is speed, and if you change your speed, this is reasonable to change sample rate, since frame is just default value, but the less speed you will use, the less sample rate should be. So I will use frame right now, and okay, as you expect, speed property defines speed of your playback, so you can set it to some real high value, like 5, and it will be really fast, or you can set it to like something really slow. And you see now let's start playback, but since sample rate is only 1 frame, you don't see all the movements between these samples. So here's when why you should change sample rate to something less, like this one. Oh, and also this doesn't work if you don't have interpolate. So this is when you have to use it. And when interpolate is on, here you can see you get update each frame and how it looks like in real time. Like really slow explosion. Can make it even a really slow explosion. So you don't need to mess up with time scale during simulation. You can just create simulation with regular speed and then edit the speed as you want using cache file. Another one feature in this speed property is that you can animate it. So let's say I will have 1 by default, it's my speed. I can open it in track view, playback speed. Actually it's easier, it's better to show you using this. So I want to start explosion, and let's say at this time, this frame, I want it to become slower. Here's my playback speed property. Okay, so I will insert keys. One key will be here to define the start, and then it will go slower, like really slow, and then back to regular speed. Okay, something like that. Okay. So here's my animated speed right now. Here you can see how it changes through time, going really slow and then back to regular speed. This is how it looks like in real time. Now it will be even less slower. Okay, something like that. Okay, I will delete this animation. So this is how the speed works. And next property is reverse playback. If you check it on, you will see the last frame of your cache animation, and if you will start playback, you'll see how it starts playing, well, back. Sometimes you need something like this. So instead of caching all the animation, edited animation, you can cache simple animation and then reverse it in here, just checking this checkbox. Okay, next property is playback graph. So in some cases you may need something specific, not just speed adjustments. So in this case you can use playback graph. You need to enable it, and right now nothing will happen since this frame property is not animated. So you can define some maybe even static state of your cached animation. There is no animation because the property is not animated. So to get some animation, you need to animate this frame property again, and we have frames. So you can start with 0, then playback it, animate it as high as you want. And then make it faster, or make it slower. Well, you can animate your animation how you want. Maybe make it back to 0. Just need to animate this frame property. Okay, I will delete it, and of course, well, I will delete it. Animation. Next property is this element activation, and to use it you need to use this gizmo subobject element. So you have to here how you can open it. So here's the gizmo, and it doesn't have any animation. And right now your simulation, I will turn off this enable. Okay, so here's my original animation right now, just an explosion. If I will use element activation by gizmo, nothing will happen because none of the fragments were not activated yet. If I will move gizmo here, only this part will be exploded because only these fragments were activated. You can scale it more, get more fragments. So you can use it to partially activate playback, but also you can animate it. Let's say start it here, and then set it to here, and here how it will work. It will start moving and start activate your fragments. Another way to activate is using OmniLight, and you may use this in case you have several cache objects and you want just one object to activate them. So since this gizmo belongs only to this cache file, you won't be able to use it for other objects. But let's say if you have 2 cache files, you can create OmniLight. And use its far attenuation to activate. So I will pick this OmniLight here in this cache, and I will pick it in this cache. And now I will animate this OmniLight. And here are how it works. Okay. So here's how activation works, and let's get back to Gizmo. And here's interactive updates, in case you want to get some interactive update when you're moving your Gizmo, so you can just use this. And in case you have very fast moving Gizmo, it's reasonable to decrease sample rate. Okay, now let's get back to original animation. Now let's see how works this out of range types. So first one is before, which means defines the state of the geometry before start frame. So let's set start frame to 20, and by default out of range before is hold, which means that it will just keep the mesh as it's its first animation frame, and then you'll start to see the animation. And of course you can check it to hide, so you'll start to see animation only where you started, and loop, so see the last frames of end of animation and then see it again. And ping pong, well, it actually works pretty close as point cache modifier, and the same for after state. And again, it's hold by default, so when your animation stops, it just holds the last state of the geometry. And the next properties are load type. The local means for the local machine, and slave means for the render farms. So stream means that it will load each frame into memory and will keep this information inside memory. And the next one is per sample, which means that it will load into memory only the sample, only the frame you need right now. So if you don't have a lot of RAM, it's better for you to use per sample one. And the last one is preload, which means that when you will load the sketch file, it will load all animation right away into the memory, and it will be the fastest. But in this case, it will take a whole RAM right away. So if you have a lot of RAM, you can use preload. And the same for the slaves ones, except that you cannot use stream for slave nodes. Okay. Now I want to show you how works this per element control rollout. So it's pretty hardcore actually, and you probably won't use it all the time, but it might really help you in some cases. So to use it, you need to go to the elements sub-object level. Now you see all the elements here, and you can select these elements and create new groups after you select them. So first of all, I will select all the fragments, create new group, and call it holding. Okay, so right now there is one group, contains all the fragments, and here are the group elements, different operations. The most important part is this group action. As you can see, it holding by default, and this means that I will not get any the elements I just added in this group will not be playback. You will not see animation from them. So now I will select another group of object. Let's say this one. I will create another group. I will call it offset 15. So for this group I will set here offset, and my offset will be 15 frame. So if I will start playback, I will see that it explodes with some delay. I can define another group of objects, create another group, set offset 30. And for this group I will define offset as well, but I will set it to 30. And here what I have right now, as you can see, objects which are not in the groups, which are in holding groups, they are not animating. The fragments in offset 15 have 15 frames offset, and fragments in group offset 30 have 30 frames offset. So they start playback with this offset. Also, I will select some fragments and define another group, set it hold out. For this group I will check here hold out state, and in this case I will see their end frame state. So they won't be animated, but they will looks like they were already exploded. So here how this per element controller rollout works. You can have only one cache, and you can create different you can just copy all the stuff, all this cache object, and get completely different results using just one cache. I think I will need to create just a separate tutorial for all this rollout, just to show all these properties. Otherwise it may take a lot of time right now. And okay, the last one rollout is explode to objects rollout. What it just takes all the fragments, all the cached fragments, and detach them and bake back to animation. I will delete all this group right now. I don't need them. And okay, here's I will to make everything faster. I will use select elements only. I will select some elements like this. And here's my timeline, which I want to explode them. And I will just click explode. Take some time. Bake everything. But now here are my original fragments. This original animation. So there are still each fragment has so if later you will lose your original animation, you always can explode everything back. Okay, now let's finish with this cache file, and let me show you how to use invisible feature, support for visibility track. So okay, here's my very simple scene setup. It's a glass demolition. I will assign some material with opacity. And here how it works right now. When you demolish glass type objects, usually you get this original object with animated visibility track before impact, and after impact you start see all the fragments. So right now my render looks like this. On next frame it looks like this. The reason I can't use the fragments before impact because I will see all these inner faces already, so I will see it already broken even before impact will happen. So this is why RayFire keeps this original object and animate visibility for original object and for the fragments. So if you will cache all these fragments, all this demolition, RayFire will cache, let me add stuff, code. So here's my cached animation. Here's how it looks like. If the object when it was cached was visible, you will see it, and if the fragments were not visible, you will not see it. Instead of fragments, you will see these crosses, and if you don't want to see them, you can use these draw markers or hide. So right now you have one object, and it looks like on renders it looks like this, but after impact happen, you will see something like this. So this is what means the visibility track support. Another feature which allows it to do this RayFire Cache is that you can assign, if you will assign edit mesh modifier, you will see that all the faces which were selected on fragments still selected for this cache object. So you can assign RayFire Cache modifier, and as you know, it removes all the inner faces. So if we will set weld here and hide edges, this is what you will get. It will start revealing fragments, only the fragments which started moving. This part of fragments were not moved, so RayFire Cache removed all the inner faces. This fragment started moving, so you can see these faces right now. So in this way you can create pretty interesting results.